आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सोल्यूशन पाओ। डाउनलोड नाउ।
Hello students, today question is the force of resistance encountered by water on a motor boat of mass m going in still water with velocity v is proportional to the velocity v. Okay students, at t equal to 0 when its velocity is v comma 0. Okay, then the engine shut off. Find an expression. Okay, find an expression for the position of motor at time t and also the distance traveled by the boat before it comes to rest. Take the proportionality constant as k greater than 0. Okay students, now let's move to the answer. First, boat. For boat going this direction. Okay students, so boat going this direction. And water. Okay, force it is in direction. Okay students, so force it is in direction. We already know that force equal to, everyone knows that force equal to mass into acceleration. Okay students, so this is the formula, mass into acceleration. So here force and velocity, here velocity is opposite to the force, right? So therefore force equal to minus kv, opposite side velocity, so I am going to my negative here. Okay students, so here acceleration, okay, everyone knows that the acceleration, so I'm going to find the m into a. Here the acceleration is a equal to dv by dt. Okay students, so velocity due to time acceleration, so I'm going to substitute here. So minus kv equal to m into force equal to mass m into acceleration dv by dt. Okay students, so this is what we are equating here. Now I'm going to integrate this one. Integrating this one, I'm going to integrate where t equal to 0 and velocity equal to 0. Okay, at starting point, starting time velocity equal to 0 and starting velocity equal to 0. So I'm going to integrate this one. Integrate this one, I'm going to get the t value and v values of one side. So here minus k dt divided by m equal to integral dv by v. Okay students, so if I integrate this one, we will get, okay, if I integrate this one, we will get minus kt divided by m equal to log of v. Okay students, log of e, the range value is, here I am going to put the range value. So velocity is from 0 starting to high, time also from starting to high. Okay so the value is v0 to v. Okay students, so if I substitute the range value, we will get minus kt divided by m equal to v by v0. Here log value will come. Okay students, now I'm going to simplify this one. Okay students, now I'm going to simplify this one. We will get velocity equal to v0 e power minus kt divided by m. Okay students, so this is what we will get the velocity here. Okay students, next, now we are going to find the velocity at the time t. Okay, where velocity, okay students, velocity at the time t, velocity at time t. Okay students, so the velocity equal to ds by dt. Okay students, so I'm going to equate this, v equal to, substitute this here, so I'm going to equate this both equation. So we will get ds by dt equal to v0 e power minus kt divided by m. Okay students, now I'm going to find the distance. Okay, I'm going to find the distance here. So I'm going to take the t to the right hand side. So ds equal to v0 e power minus kt divided by m into dt. Now I'm going to take integrate on both sides. Okay, so integrate ds. So this is starting position and this is the end position. Okay, equal to integral velocity is always 0 to time at the time t, velocity at the time t 0 to time t. So v0 e power minus kt divided by m into dt. Okay students, if I take differential, it will become yes. So I'm going to substitute the value s minus 0, it will become yes. Directly I put s here. So here v0 is common, okay, because it's a constant term. I'm going to take outside. So v0 and m, it will come m by k, m by k into e power minus kt divided by m. The value is equal to 0 to time, the range value. So if I substitute the range value, we will get minus. Okay, minus. So here minus value is there, I'm going to put here, so I forgot here. So minus value, so minus v0 m by k into e power minus kt divided by m, because I'm going to substitute t value here. So now I'm going to substitute the t value equal to 0, it will become e power 0 is 1, so minus 1. Okay students, next if I'm going to take this minus outside, cancel, I'm going to need to cancel this one. So I'm going to interchange this one. So if I interchange this one, minus will come, I'm going to take outside, so minus minus plus. So v0 m by k equal to 1 minus e power minus kt divided by m. Okay students, now okay, so this is the s value here. So this is the s value. So I'm going to substitute the limit, okay, because we have to find the time. Okay, so at the time of infinity, from to infinity, where is the position? Okay, so distance traveled. So I'm going to write down here limit of s t is at infinity. So limit of t equal to 0 mv0 divided by k into 1 minus e power minus kt divided by m. So I returned this, I returned here. So if I substitute the value, infinity to 0, we will get this value became 1. So 1 became 0. Okay, so this value became 0. So the remaining terms are s equal to mv0 divided by k. Okay students, so this is the distance t before yes. Okay students, before. So we found that s equal to mv0 divided by k. Okay students, so this is the answer. Thank you.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।